Okay, yeah, so that's me. I'm Martin. I'm not only asking questions, I'm also product owner for our Kubernetes team. And in that part, I'm talking about visibility into Kubernetes today. And as already said, we have worked really hard over the last months so that we can actually deliver something for the conference, and really happy that it's now actually available. If you try out one of the current betas, it's mostly is there, it's already in a good state. We have actually a lot of users who are using it already. It's a beta, yeah, but a lot of them are using it already because they like it, yeah, which makes me happy, yeah. So give it a try, of course. And today I will speak first about what it is actually about, what have we done, why is it good for Kubernetes users, how you can then actually get started, and then I will give a brief outlook on what is next. So, we built this new Kubernetes monitoring with the support of a lot of people who are actually here, a lot of Checkmk users, but a lot of people who are actually not Checkmk users, who are Kubernetes experts, yeah, to really get their know-how into it, who work, for example, a lot with Prometheus and Grafana, and to understand how do the actual Kubernetes native people think about a monitoring, yeah. And we built in this expertise for you, and there are a couple of things which you then benefit, of course, from. First thing is, we try to make this complexity really simple, the complexity which is inherent in Kubernetes. The other thing is, I mean, okay, complexity solved, of course, yeah, then you obviously want some actionable insights. You don't just want data dumps. And then data is nice, metrics are nice and stuff, but in the end, I mean, we do monitoring, so we want alerts. And we want intelligent alerts, we don't want to be over-alerted. And then another here fancy word, multi-anything ready. I will explain what this is about later. We have also built it for dynamic workloads because we all know Kubernetes is dynamic. So we should for sure make sure that this works with Checkmk as well. Then reliable support. What does it mean? If you have looked into forum over the last couple of months or years, you know what it means. It means that you can also use it for the latest Kubernetes versions all the time. Yeah. And the last thing is, of course, you want to get it working in a quick setup really fast. You don't want to waste a lot of time in actually setting up what we're doing there, yeah? So we also worked on that and delivered that, I hope. Okay, first topic, complexity, yeah? When I first tried the Kubernetes monitoring of Checkmk, I think 2 years ago, this is what I looked at. And I mean, it's basically like this. And I was a little bit taken aback because I was like, okay, I have all these hosts. I have now several hundred hosts in Checkmk, and I don't know what it all means. Yeah, and this is something which is not just happening in Checkmk. In all the other tools which I tried, which do Kubernetes monitoring, it's always the same problem. And this is something which is inherent in Kubernetes, that you just get this host overload. And in typical installations, you have hundreds to thousands of objects. And a table like this, I don't think that's a great solution, because how do you navigate there? How do you know what to do? Yeah? And I thought, hey, we need something better. But to understand what we actually need, let's jump first into how Kubernetes works. And don't worry, I will not explain Kubernetes, because then we will be here for another month. I still don't understand it completely, but I think that's for everyone like that. Kubernetes is complex. Not only for beginners, but also for experts. It just gets more complex the more deeper you go into it. And I tried to simplify it, how it works, to give a feeling how is it structured. And the first thing is you have a cluster. Yeah? But you don't have only one cluster. You of course have many clusters. Can be up to 30 clusters, which I heard from some people, and I mean, you can do that, of course. Yeah. Then you have the nodes running on your cluster. These have the workload on. This is where everything, all the fun is happening. But you don't structure the workload via the nodes. You actually use namespaces mostly to structure your entire workloads. Yeah? Think of a namespace like, for example, you structure it for each project gets a namespace, each team, for example, gets a namespace. I've seen also that people use namespaces to separate production environment from dev environment from test environment. You can do whatever you want, that's up to you. Yeah? Inside the namespaces, you have the actual applications running. Could be, for example, something like a deployment. Whatever that means, yeah? I know, of course, but inside the deployment is, for example, a pod. And inside that pod is the actual container running the application. Yeah? But of course, you don't only have a deployment, you might also have a daemon set, which is just particular that it has a pod running on each node. You have more things like stateful sets, and I think this has already shown, okay, hey, there's a lot of things happening. It's kind of a multi-layered structure. It's complex, and don't worry, it's much more complex. Like you have many, many key concepts which are completely excluded because, I mean, it's already complex enough, isn't it? Okay. For me, with this complexity, it's always very difficult to actually see the forest for the trees. Yeah? And so we thought, okay, how do we solve it? And one of the ways how to solve it is with dashboards. And Marcel talked about dashboards yesterday, and Marcel was a great help for me because he told me how to do dashboards, which saved me really a lot of time. So believe me, listen to his talk again and then build your dashboards. It took me only 10 minutes to build decent dashboards instead of many, many hours or days. Yeah? And I will go into how the dashboards look in detail later, but this is just for the structure. So to deal with this complexity, you need to structure the information. And dashboards are the best way for that. In the beginning, you always should start with a high-level view on the cluster. You need to know what is actually wrong. You need to have some kind of overview. How's the performance? How's the status of my workloads? And then you can start to drill down. And that's really nice about Checkmk because you have many, many features to actually go deeper. Yeah? And that's a starting point. You then go deeper, for example, to say, hey, I want to see the namespaces. I want to see that specific namespace and everything which is happening in that namespace. Or you want to see the node, or daemon sets, deployments, stateful sets, and so on. Yeah, so you can then drill down into the layer to see the information which is then relevant for you. For example, if you go to the namespace, you have a different dashboard which only shows the information for that namespace. And from there on, you can go deeper again into this rabbit hole. These dashboards have another great purpose. In Kubernetes, I think admins / DevOps or application developer, application teams work really closely very often together. And each of these teams have different needs and perspectives. Most of the cluster admins or Kubernetes admins, they care about the big picture of the cluster. Is my cluster healthy? Do I have enough capacity left there? Or they also look a lot into the nodes. Whereas the application teams, they have a very different need. They don't care about the nodes because that's not their problem. That's a problem of the admins, yeah? They are interested into their namespace where they have the stuff running or into their deployment where the application is actually running. So by providing dashboards, you can provide, for example, to your users what they actually need in information. So let's jump in an actual dashboard. That's the cluster dashboard. And as said, plenty of times, we spent a lot of time to build the right dashboards. Thanks for everyone who gave feedback. It really helped a lot to see, okay, hey, this is how you think about it. And we built these dashboards so that you, as users, don't have to build the dashboards, but you can actually spend time on fixing stuff. Yeah? The cluster dashboard is structured in, on the right side, performance. You can see CPU utilization at the moment of your cluster, but also how it developed over time. You can see the same for memory, but you can also see, do you have any capacity constraints? In this case, we see really big in red, I don't have enough free pods. I only have 2 pods left in my cluster. This is not really cool. Yeah? So you should, for example, add another node if Kubernetes doesn't do it itself. Yeah? You can, of course, see all the problems of the cluster in the classical table view, which is, I think, really nice as well. Besides the actual performance, I think it's also of the overall cluster, it's important to look into your actual workloads. And on the bottom, you can see actually daemon sets and deployments where, for example, some applications are running. And you can order them by memory consumption or CPU consumption to see who is really the heavy hitter in your cluster, to see who is consuming all the CPU on your cluster, who is consuming all your memory in your cluster. And you can order that to see, okay, hey, where is something going maybe wrong? And especially you can see, hey, something is red. Maybe I should look into that. And you can do that. And if you do that, you get into the next dashboard. This famous drill down methodology. And here we can see directly the status of every we see first, for example, the performance, CPU memory of the deployment overall, but also of the individual pods, to see if there's some outlier happening. But you can also immediately see, hey, what is actually wrong? Yeah, we saw some crit here, and we don't need to understand what it actually means. Yeah, you want 6 and you have 5. You want 6, so red. Yeah. All these dashboards are nice, but they're actually pretty useless if you don't have the right data. So actually, the most time we spent was not the dashboards. Most of the time we spent on architecture and redesigning every single service in Kubernetes. And because without the right data, no dashboard will be helpful for you. And our classical service view, I think this explains best what we did to provide you actual actionable insights into your clusters. We redesigned every single of these services, and we tried to get rid of useless stuff. We tried to aggregate stuff into the right thing. You don't maybe want 5 services for each condition, which Kubernetes has a service. You just want one service, for example. Yeah. And more importantly, you want context information. Let's take a look at this specific CPU service and into the graph. And you don't only get the configuration data, because that's a little bit special in Kubernetes. You have the configuration world and you have the live performance data world. And the application developer says, okay, I have this limit on my application. I don't want that this application consumes more than the limit. That's what the application team does. And then you have the actual performance happening, and you want to know how these things actually match together. And that's one of the big new changes. You can actually see now the usage versus the actual configured limits, because if your usage goes now, for example, to the limit, that's why we also calculate limit utilization, your application will get throttled by Kubernetes, which is not a nice user experience, so it's something worth looking into. Okay, so we saw some services, nice for application teams, but as most of you, I guess, are admins, let's look at the stuff which really matters for most of you, that's nodes. And we spend a lot of time on actually improving the node monitoring in Kubernetes. Again, our services, and I think the service list is well known, so the important part here is that Kubernetes itself is very limited in its perspective. Kubernetes knows about itself. It doesn't know about what the other things are doing outside of itself, yeah? So it only knows, hey, I have this CPU usage which Kubernetes objects are consuming, but not what other things are doing, yeah? You know some stuff on how many resources you have but that's only Kubernetes stuff, yeah? You're missing the really important stuff. You're missing the stuff the Checkmk agent does. Yeah, so I think this is mostly familiar, the stuff on kernel performance, file systems, and CPU utilization and stuff. And that really matters because if you, for example, have an application dumping everything into the file system, Kubernetes will not tell you. The Checkmk agent will. As well, if you have an application spawning a lot of zombie processes, and actually this can happen, we have seen it, your number of threads will, for example, go up, and Kubernetes will also not tell you that. But Checkmk can tell you that. So fusing these two information sources was really important for us, and doing that natively in Kubernetes. We'll go into that, why this is special a little bit later when we go into the architecture. So we saw some data, some stuff, but in the end we want alerts. And we, of course, did a couple of built-in alerts, and we focused that we only alert on things which actually matter. Yeah, and which matter for everyone. We don't want over-alerting, but we also want that you have the flexibility to configure alerts for everything which you want and need. Yeah? So by default, there will be hopefully no over-alerting. If there is, send me an email. Here we have an example of a deployment dashboard, and we can really see our red thing again. And the good thing is we can click on, for example, the service to see of the pod what is actually happening, and we can see all the details in there. So when you get your SMS or your email, you can see, hey, in the details, the Nginx is missing its config map. That's why it's not being started. So you know you have to get up or not in the night, or you can just continue sleeping. Another special thing is, if you look, there's this timer. Yeah, it will not immediately alert by default, because we all know Kubernetes can heal itself. Yeah, so let's give it some time to actually heal itself if it actually does it, and don't alert immediately. And this is one of the key things which we now made different. It will just always wait for a couple of minutes before it actually goes into a warn or quit state. But for example, if it doesn't fix itself after 10 minutes, that was, I think, our best practice experience that you got from Kubernetes experts, like, then it's really a problem, and then you should really look into it. You can, of course, configure that. So besides the built-in alerts, you can, of course, create your own alerts. And for almost every service, we build rule sets so that you can actually build alerts yourself. And the common way in Kubernetes for non-Checkmk users is to write queries like this. This example is how much memory is still available, or how much memory is underutilized in your cluster. I believe this. I do not know this, and I really don't want to know this as well. I don't know who has fun doing these things, but I did that during my studies, and I'm not sure if I still want to do that. Yeah, because my key issue with that is queries that are like this are prone, and I think most people are just copying them from the internet and don't really know if that's really working or if that's doing what they actually want. The second problem I have with that is you need to know what these metrics mean. And believe me, it's more complex than just taking it. I think we spent alone 2 days understanding the difference between memory usage bytes and memory working set bytes. And there is a difference. And I don't know if you as a user want to spend that time if you don't have anything else to do. Yeah, we think we do it better. We do it in the Checkmk way. We try to solve this problem for you by looking into it, by understanding what it means and choosing the right metrics which matter. So that in the end you have rule sets like that, which you know from Checkmk, and where you can just say, okay, I want this alerting like that. And we build a lot of labels into Checkmk now. So coming to labels, a lot of labels automatically being generated, and there are some which are imported from Kubernetes, and several which we found useful ourselves when we did our alerting for our cluster and when we built the dashboards, because you need these labels to have some context information. Which cluster is this actually? Yeah, and after I showed the new Kubernetes morning in the last community call, I said I got all these emails and everyone wanted the same thing. And then I said, okay, should probably make sense if everybody wants it. And that was, I want to import annotations from the application. Yeah? Because the application developer knows I want 9 to 5 monitoring, or I don't want any monitoring at all on that application. Yeah? And they can define annotations in Kubernetes themselves. That's a built-in feature of Kubernetes. And now you can import these annotations based on how you define it as the monitoring admin, and then use these labels for your alerting automatically, so that it's just less work in the end, and you have this monitoring as code concept. Okay, so now we have a lot of this alerting and stuff, and now the next question is, okay, we have our one cluster. How do I deal with multiple clusters? Is that a problem? No problem. You start always, when you look into the Kubernetes dashboards, with a cluster selector view, because you will have multiple clusters, and you need to know, okay, which cluster do you actually now look into, and then you get some meta information around the cluster, some performance information, and you can go, okay, go into that one. And as you can see, we thought about this from the beginning on, and for us it works so far. Yeah. Now, clusters are one way how you can structure Kubernetes. The other thing is namespaces, as said before. And with namespaces, you can have the problem that you have really a lot of namespaces or just a few. Yeah? And you need to be flexible on which ones you want to exclude from your monitoring and which ones you want to include. And so we built both options in. You can just say, hey, I only want to exclude like the test namespace, or I only want to include these 3-4 namespaces. If I have, for example, 50 namespaces, and I only care about the system namespaces, and I don't care about the application namespaces. Okay, so now we have that. Let's go to dynamic. In Kubernetes, pods are there, then more pods are coming, some pods are going away. And yesterday, Lars talked about this incremental activation. And the beauty is this incremental activation and the dynamic configuration work really well together. Because the standard thing which happens in Kubernetes is I add hosts, I do a service discovery, and then I delete hosts. And this is exactly what is being sped up by the incremental activation. So these things work really great. But this doesn't solve that you have a lot of pods. And a lot of pods which you probably don't care about. A great example are cron jobs. Yeah? Cron jobs can spawn a pod, for example, every minute. And I don't know if you monitor each process being spawned by a cron job in Linux, or if you just monitor what the actual cron job does of the result of the last execution, if that was successful or not. And we say, hey, this is the same way how you should do it in Kubernetes. You shouldn't monitor the individual pods being created by such objects, but rather the aggregation layer. So that you know, okay, hey, did it succeed? When was the last successful job? And this concept applies to a lot of things. And one of these other examples is, for example, a deployment and pods. We know a deployment has multiple pods. These pods can come and go. What happens to the metrics? Gone. Yeah? But does it really matter? It matters that you have the full view on the deployment, that you know, okay, hey, I have a new version of my application which I just deployed into the deployment. How did that change the CPU and memory usage of my deployment? And you can, of course, look into detail. I don't know if you can see the little dots. These little dots are all the pods running in this deployment, so you can really see is there an outlier as well. So we do both of the information, but the important thing is on the aggregation layer, which is very stable typically, you will have the stable information to really see long-term history. Okay, what's next? Reliable support. So if you use the latest Kubernetes version, no problem anymore. And why is this important? In the old Kubernetes monitoring, we relied a lot on the official Kubernetes Python client. And that had a lot of issues. Yeah? The main issue was it was not keeping up with the developments of the Kubernetes API. And there were objects in the API which were not really stable. There were things which were not working. And that's why our Kubernetes monitoring then crashed. And we said, okay, we don't want this anymore. We want to have something which really works future-proof. And so we decided, okay, there are some stable API objects, and we use the Kubernetes Python client for that. But there are some rather newer API objects, and we use our own API calls for that, which we can then really quickly fix if the API changed again. But this is not the entire solution. I think in the end, if you really want proper support of stuff that ensure that everything works, you need a CI which tests. And the automated testing versus our supported versions is something which we are also very keen on to do, because then we can know if something is wrong before you have to tell us, so that we can work on fixing it before it impacts anyone. So I hope you might be interested in getting started. So how do you get started, for example? And we are speaking now about the Kubernetes cluster collector, so the agent running in your Kubernetes environment, which collects all the data. And we wanted to make that simple, and we want to follow best practices in Kubernetes. So we support Helm, which is the standard tooling for installing stuff in Kubernetes. And you just have to add our repository, which is on GitHub. The entire agent is open source, of course. And when you have added that Helm repo, you just do one command to install the cluster collector, and you're basically done. Doesn't stop there. It will tell you, of course, hey, wasn't there, installing it now, deployed, nice. And it goes even further. You can also see how you configured your cluster to be available, because your collector, because the collector somehow has to send data to the outside. And you can basically see directly, hey, where is it available or connectable. But not only that, for configuring the connection Checkmk, you always need a token and certificate, and you get the commands which apply to your specific installation directly, so you can just export them and copy them into Checkmk. So less work for you, more fun for everyone, yeah? So I now talked about the collector. What is this collector? Let's go into the architecture. Checkmk, Kubernetes. Checkmk special agent, I think pretty clear. The special agent talks to the API server of Kubernetes to get the scaffolding, to get all the data which is required for structuring everything for us. That's really the necessary piece. And then the recommended, but actually optional piece, but without it, it's pretty useless, I think, is the cluster collector, because from that one, we get all the performance data of the individual containers and aggregate that onto the right layers. And the cluster collector can be reached by the special agent. Cluster collector doesn't have all the data, it just collects stuff. It collects stuff from the node collectors. And there is one node collector for container metrics. That's actually a C advisor. And that pushes the data to the cluster collector. And there's another node collector, which is called the machine sections, which is a customized Checkmk agent, which pushes also the data to the cluster collector. And that is important because you will not be able to install the Checkmk agent in every Kubernetes environment on your nodes. We've seen a lot of people who have struggled with that because some nodes are very restrictive. And there's a reason for that, of course, and they want that you use the Kubernetes mechanisms to install things onto your nodes. And we do that so that you don't have to do it, that you get all this information in one view. You don't have to do piggyback hostname translation and stuff. You just get all the stuff where you want it. Okay, that's the architecture. How do you get started? Also pretty simple. The commands which I just showed before. There's a values YAML, which is not needed, but I would use it. It's also in our GitHub repository. Customize it to say how you want to connect to your cluster connector, how it should expose the data. There are two options which are the standard, which we support, which is ingress or node port. And it's just basically, I can do it, so I believe everybody can do it as well. I'm no admin and I'm no developer. Yeah. The second thing is configuring Checkmk, and that's the standard as for every API integration, standard procedure. The documentation will be coming soon. My recommendation is run the Kubernetes monitoring in a dedicated site, because there's so many changes happening and all these things. In a real production Kubernetes cluster, you will have pods coming and going, the DCD activating all these things. I recommend doing it on a special site, extra site, and then connecting it via distributed monitoring. Of course, totally up to you how you do it. And with that, you have happy monitoring. Not entirely, because where does it work? Because there is not one Kubernetes, there's many. Yeah, the first differentiation is what container runtime do you use? Do you use Docker, Containerd, or Creo? Yeah? Docker and Containerd we support officially. Creo is on the roadmap and will be hopefully coming in a couple of months, latest. And then more important, which Kubernetes flavors. So we officially support vanilla. Doesn't mean that it doesn't work on the others. We have tested it ourselves on AWS EKS, Azure AKS, Google Kubernetes Engine, VMware Tensor, and Rancher. That's where we got feedback also from users that it works. The one thing where it doesn't work because it's special is OpenShift. And that's coming soon as well. So that's our current focus, is to actually build support for OpenShift as well. A lot of other tools build their special agents for OpenShift. They can't use the Kubernetes agent there. And in the end, we'll probably do the same there because it's just very specific and very non-standardy. Then which versions do we support? We support the latest 3 versions. We follow the official maintenance cycle of Kubernetes itself, which is the latest 3 versions, which is at the moment 1.1 to 1.3. I don't know if 1.4 is already out. It should be coming this month. And then we will also support that, of course. Doesn't mean that it doesn't work on older versions, but if it doesn't, I recommend to upgrade to a later Kubernetes version. Okay, what's the outlook? What's next? As said before, we want to do more coverage. A couple of objects missing. So, for example, services, the cron drops, ingresses, volumes, horizontal pod autoscaling. At the moment, you have basically everything which you really need. These are things which are nice and good. There are a lot of interesting concepts which can be done around them, which will be super nice, I think, in the end, if we do that, and we will do that. Yeah. The other thing is what you can actually, which flavors do we cover? We will do more flavors. We will do OpenShift and the container runtime Creo. And then in the end, I think this is where I'm really excited about, is actually doing application monitoring. Because in the Kubernetes world, we have the admins and the application teams working really closely together, hopefully. Yeah? And you want the endpoints of applications sometimes in your monitoring, the metrics which come from there. And there's this concept of service monitors from Prometheus. And I actually like it a lot what it does. It basically says, okay, scrape from this endpoint these metrics and put them into my monitoring. And we want to support it as well, because then you can do actual application monitoring in Checkmk as well. And the other thing really important for troubleshooting is logs, of course, if you do application monitoring. And getting the logs in a really nice way into Checkmk is something which we also want to do. You can do it already with the event console and different things, but I'm not super happy with how it is being implemented at the moment. I think we can do it much better, and that would be the goal also to do that. That's it. I tried to be fast so that we have some time for questions as well.